Today I'm going to show you how to use something called Desmos. So we're going to use this with our linearization. So if we look up Desmos, we're looking for the graphing calculator, but if you go to the main website, the graphing calculator should be right there for you. So what we're going to do is we're going to go through how we would perform our linearization or our linear approximation for example 1 from the linear approximation notes. So we know that our goal is to approximate the square root, which you type in SQRT, of 25.5. And so we get it right there, and it tells us what that value is going to be. Well, we know that when we're trying to approximate this, we want to use as our function f of x the square root of x. So when you type in the square root of x, it'll go ahead and Desmos will give you that graph right over here. And so if we click on some of the options, we can have it go away or show up. Now for us, when we're performing our linearization, we want to be able to use a nearby point. So we said that we wanted to have our value be 25. So part of what we need for our linearization is we need to know what the function value of 25 is. And so if we then type f of 25, it shows us that the value for that is 5. We also need to know what the value of the derivative is. So if we type in f prime of x, if we just type in f prime of x, it'll go ahead and give us the graph of the derivative of this function. What we're interested in, though, is finding the derivative specifically at 25. So if we type that in, it'll again give us what that value is. Now, if we want to go ahead and create our linearization, remember that linearizations are of the form L of x, which is equal to the derivative at our nice point, which in this case is 25, times x minus whatever that nice point is, again, in this case it's 25, plus whatever the function value is at 25. And so we can type it in this way, and so we can see this black line here, and we can turn it off, turn it on, turn the blue line off, turn the blue line on, gives us the graph of that tangent line. And so if we pull ahead and look, we know it should touch at the point x equals 25, and so we can zoom out if we want to. We have some buttons here to zoom in and out. We can kind of drag on the screen if we'd like to go where we are. We can see this tangent line touches right at this 25, and it's very, very close as we get closer. So we can zoom in some more. We can even see this 25.5, the place we're interested in. It looks as though whether we're on the blue line or the black line, we can get the blue line to disappear, black line to disappear. Wherever we're at, it looks as though those values are very close together. We can see where this point is here. This dot helps signify where the two places are touching. It kind of shows important points. And so we can go ahead then and kind of look at this and use this to figure out what our approximation is. So if we typed in L of 25.5, this will give us our 5.05 for the approximation. And so we can see that this and this are very close. In fact, if we want to see exactly how close, we could type L of 25.5 minus the square root of 25.5. And we can see that this tells us how much difference there is between those two values. So they're very, very close together. So if you needed to ever go ahead and create linearization or a graph for one, you'd want to make sure you not only graph the function, but also the linearization. So again, a lot of this stuff around here is extra fluff. We didn't need to do this. We didn't need to do this or this or this or this. If we wanted to create our graphs, we just need to type in what our function is, and then we also can type in what our linearization equation looks like. And so again, this part will change. The 25 will all change to whatever value you're using as your nice value or your value to help approximate. And this is kind of just that general form for linearization. And then from here, say you wanted to go ahead and take a screenshot, default zoom. There are some things you can change on here, but I'm fairly certain there's nothing that lets you just kind of take an easy screenshot. So you have to figure out how your computer takes screenshots if you wanted to do that. We also could look at, while we're here, if we wanted to replace this with, say, sine of x. So we know our sine function is what we have. We don't want this black line yet because that doesn't quite mean anything. And we wanted to approximate around 0 our graph would look like. So if we then put our black line back on, so as we look here, the blue function is sine, and this black line is that linearization. And as we look, this is really just, because the derivative is 1 and the sine value is 0, this is really just the line y equals x. So in fact, if you take L of x minus x, notice you get this green line here that is just 0 all the way through. So we don't need to see that. But we can kind of very easily verify here, as we get values that are very close to 0, sine of x and our linearization almost appear to be exactly the same. So just something else neat we can do. So really just need the function and then knowing what a is and how to set up our linearization equation.